Welcome to my presentation. In this presentation, let us try to solve system of linear equations using graphical method this time. The example what we have here is as follows. We want to solve this system of linear equations. 2x, let me write this a little bit more clear. 2x, not able to write x, 2x minus y is equal to 0. That is equation number 1. And the second equation what we have is negative x plus 2y is equal to 3. This is equation number 2. We will use graphical method to solve this problem. Graphical method. How do we do that? Let us take equation number 1 in step 1. Let us take equation 1, which reads 2x minus y is equal to 0. This is in the non-standard form. The standard form of a straight line is y is equal to mx plus b. So I want to write it in that format. So therefore 2x is equal to y, or I can write this one as y is equal to 2x plus 0. This is in the standard form. Y is equal to mx plus b. In here, m is 2 over 1 and the value of b is equal to 0. We've identified the slope and identified the y-intercept. We'll do the same thing for equation 2. And then we'll go back to our graph sheet and then plot it out. The second equation given to us is negative x plus 2y is equal to 3. So we can write this as 2y is equal to x plus 3 by adding x to both sides by using the addition property. We want the value of y. Y is equal to, dividing both sides by 2, we have x over 2, we have x over 2 plus 3 over 2. And now this is in the standard form. Y is equal to mx plus b, right? And therefore we can identify the slope, which is 1 over 2. We can 1 over 2, 1 divided by 2, and then we can identify the y-intercept, which is 3 over 2, like that. Okay, so now that we have the slope and y-intercept for both these equations, we are now ready to plot them out. Let's go to our graph sheet. Let's draw a graph sheet. Okay, let's draw a graph of these, and let's say we have something of this nature. Let me do it this way so that we have the entire screen to view. So I'm going to, this is the y-axis, hopefully that is a straight line, and this is my x-axis, and the point, this is the positive x-axis, this is the negative x-axis, this is the positive y-axis, and this is the negative y-axis, and this is the origin. That's the origin. And if I were to pick some points on the x and y-axis, if I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then on the y-axis, if I have 1, 2, 3, 4, 5, 6, and on the y-axis I could have point on the x-axis and a negative x-axis and negative y-axis. That would be negative 1, that would be negative 1. And then if we need more points, we'll come back and then pick them out. So from here, in the first equation here, I'm going to use these different colors now and to represent. In here, the slope is 2 over 1 and the y-intercept is 0. That means we'll identify where the y-intercept is. The y-intercept is right at the origin, and we want to superimpose the slope on top of the y-intercept. So what is the slope telling us? Slope is always slope is telling us that we're going to rise 2 units and run 1 unit. We're going to rise positive 2 units. That means from the origin we're going to travel 2 units to the top. I'm going to put a dotted line and then put an arrow where it ends, and then we're going to go 1 unit to the right because that is a positive number. We're going to travel on the positive x-axis, so therefore that is where it ends. I'm going to put a circle wherever we end, and I'm going to draw a straight line passing through these 2 points like that. Hope that is a straight line. Okay, then, and this is passing through the origin. This line is passing through the origin. We got that. Now we come to the second point, and then this time I'm going to represent that by a different color. Here m is, for the second equation, the slope is 1 over 2 and the y-intercept is 3 over 2. 3 over 2 means 3 divided by 2 is 1.5. I want to write it in a decimal format because we have numbers located in here. 3 over 2, we know it is 1.5, but the point is we want to know between which 2 points does that 3 over 2 fall. So 3 over 2, when I simplify to a decimal number like 1.5, then I know that it is greater than 1 and less than 2. So 1.5 is going to be right in the middle there. I'm going to put a circle around it. That is the point where I want to be, and from there I want to come back and then superimpose the slope on top of that. The slope is, the rise is 1 unit and the run is 2 units. The rise is 1 unit, that means I'm going to go till 2.5. That will be 1 unit going up and then 2 units to the right. 2 units to the right, and this is 1 unit here, and then the second unit is going to be right there. So therefore I'm going to travel to the right that way and put a circle around it, and now I have these 2 points. This is one point and this is another point, and if I were to come back and then draw a straight line connecting these 2 points, and this is the line, these 2 lines, this blue line and the green line, are intersecting at a point. The point of intersection is right there. The point of intersection is right there. I'm going to represent that by a red dot and a red circle like that. And before I go any further, I want to represent this as the first line, which is 2x minus y is equal to 0, or we could have also written it out as y is equal to 2x plus 0. This is how we can represent that line as a straight line. And the second line here, this is a representation of negative x plus 2y is equal to 3. That is in the non-standard form, or in the standard form we have written it as y is equal to x over 2 plus 3 over 2. Okay, so that is how we can think about it as the representation of that line. When we did that, we've seen that the point of intersection is going to fall on is going to be there, right there where the red line is indicating. So if I were to project that onto the x-axis and project that onto the y-axis, we see that the x-ordinate for that is 1 and the y-ordinate for that is 2. So the value of x is 1 and the value of y is 2. The value of x is equal to 1, the value of y is equal to 2. And that is our solution point. That is where The point of intersection is the solution point for this system of linear equations. What is that point telling us? The point is telling us that that is the only unique point which satisfies the equation 2x minus y equals to 0 and negative x plus 2y equals negative x plus 2y is equal to 3. Those are the given set of linear equations we have. Okay, so this is the way we want to be able to visually see what is happening with this system of linear equations. Where is the point of intersection? So in as long as the system of linear equations are simple like this, that is with the two unknowns like this, we should be able to visually see it. When we look at system of linear equations in 3 variables or more than 3 variables, it'll be difficult for us to visualize, because those are going to be those are going to be representations of planes, and to visualize those planes would be a bit difficult, but we should be able to solve them using some advanced methods and be able to either get a plane of intersection, a line which is the intersection of two planes could be a line, or the intersection of 3 planes could be a point. We will see all of those as we move forward. So in my next presentation we shall look at some more examples as to how to solve system of linear equations using advanced methods.